Alright, let's look at the homework 11, problem number 5. Alright, so for this given matrix M, we want to find the eigenvalues and eigenvectors, and let's do that. Alright, so as usual, we just need to solve this equation, determinant. Alright, remember that we subtract the lambda, which will be an eigenvalue, from the diagonal element. So you have A minus lambda, and you have H, and the H here, and we have B minus lambda. Right, and this determinant has to be equal to 0, right, because we want to be able to find non-trivial solutions. Alright, so if you work that out, you're going to get, so this is going to be, alright, determinant, so it's A minus lambda times quantity B minus lambda, right, minus H squared. Alright, so this is equal to 0, and multiply it out. We're going to get A times, so you're going to have A times B would be AB. Right, then A times negative lambda, so negative A lambda. Negative lambda times B is negative B lambda. And a negative lambda times negative lambda would be plus lambda squared minus H squared is equal to 0. Right, and collecting the like terms. Right, so you have lambda squared. Right, so together, and then we have negative A lambda and a negative B lambda. So we put together, so it's a minus A plus B lambda. Right. Then the rest is just the a constant term. We have AB and a minus H squared. So we have so plus AB minus H squared is equal to 0. Right. So we have that. Then we have a quadratic equation, so we can solve for lambda. So we use the quadratic formula. So lambda is equal to, alright, so notice that here, this is the, A value is 1, so here's A value. And B is negative A plus B. And the C value is right here. So this is C. Alright, using the quadratic formula, so it's negative B, which is A plus B, alright, plus or minus square root of, alright, B squared, so which is going to be just A squared plus 2AB plus B squared, alright, minus 4 times A is 1 times C is AB minus H squared, and all over 2 times A, so 2 times 1. Alright, then we can simplify a little bit. It looks still ugly, but A plus B plus or minus, right here. So we have A squared here. So I put A squared. And we have 2AB, and there's a minus 4AB, right? So it's going to be negative 2AB, right? And then you have plus b squared, right? So you have plus b squared. And then we have a negative 4 times negative h squared, so it's going to be plus h squared. Right, then all over 2. Right, and then this is equal to a plus b plus or minus square root of, looks like this is just going to be a minus b squared, and it looks a little bit better, plus h squared over 2. Alright, so these are the two eigenvalues. So we can probably take the positive version as a lambda 1 and a negative version as the lambda 2. Alright, so those are the eigenvalues. Alright, so let's see. So maybe I'll do it this way. So instead of writing it this way, maybe I'll write it here. Alright, this is lambda 1. And then the negative version, so I have to erase this guy right here. Right. Then lambda 2 to be a plus b minus square root of just same thing, a minus b squared plus h squared over 2. All right. So those are the eigenvalues, right? So let's find the eigenvector corresponding to lambda 1. So we want to find, say, I'm going to call it the v1, right? So we want to find that, right? First, I'm going to have to make some room. So hold on a sec. All right. So what we need to do is remember that a minus lambda. So we're going to do a minus lambda 1, which is this guy, so it looks really ugly. 4 plus b, right? Not 4 plus b, a plus b, I meant, square root of, right? So a minus b squared plus h squared, and all over 2, right? Then times x. So this is the coefficient of x. So I'm gonna, let's see. So this is times x plus hy equal to 0. Right. So this is the first row of the matrix. You know, a minus lambda and h there. So you have, this is a minus lambda 1 plus hy. Alright, so we're looking for x and y which satisfy this equation. Alright, the reason why I'm looking at only the first equation is that the second equation is going to be identical or equivalent, so there's no need to look at that. Alright, let's simplify this a little bit better. Alright, so if you solve for say, I'm going to put this guy over to the other side, you're going to get hy is equal to, so this guy is going to be negative, so you're going to have 2 on the bottom, a plus b plus square root of a minus b quantity squared plus h squared. Right, then we have to subtract a, because plus a becomes negative a on the other side. Subtracting a, so it's going to be 2a over 2, subtracting it, so it's going to be negative a over 2, right, x, right. Then here you can divide through by h, so that h is, I'm going to erase that h and put h here, right. So this is the equation x and y of the eigenvector has to satisfy. So I'm going to look for something fairly nice so that it looks a little bit better. So I'll take v1 to be, so be v1 to be, so which is going to be x comma y, right? So to make this expression fairly simple, it's still going to be pretty ugly. I'm going to take x to be 2h, right? so that 2h here and the 2h here cancel out. So y is going to be this expression. So y is going to be negative a plus b plus square root of a minus b squared plus h squared. Right? So that's going to be the eigenvector v1. Right? So you can do the similar thing to find the eigenvector v2. Right? So you just have to use lambda 2 here, then do the same thing. Right? So that's for part A. I think I gave you enough to work with. And part B, show that the eigenvalues are real. Right? This one is actually pretty simple. Look at the eigenvalues. So here is the eigenvalue. The eigenvalues. Right? How do we know that this is real? Right? All you really have to pay attention is this guy. Right? The guy inside the square root here, and the same thing here. Right? We just have to show that this guy is non-negative, and it's pretty easy to see that it's non-negative. So I stop there. So that's part B. All right, and show that the eigenvectors are perpendicular. Right? So once you have V1 and V2 for part C, so this was part B, and for part C, all you have to do is show that the V1 dot product with V2 is going to be equal to 0. Right? So find the V1 and V2 and show that the dot product is equal to 0. Right? That's it. I hope that this was clear.